In this video we're going to introduce implicit differentiation, and we're also going to show how you can find the second derivative with implicit differentiation as well. Let's imagine we wanted to differentiate a function of y. So I want to differentiate it with respect to x because typically that's what we're going to be doing. So if I try and differentiate y with respect to x, there isn't much I can do. But wait a minute, this is exactly the same thing. So I multiply by dy by dy, then I'm effectively multiplying by 1. And applying the chain rule, I can switch these around, so I end up with this little formula here, which is really helpful. So if I differentiate something with respect to x, which is a function of y, I can differentiate it as if it was with respect to y, and then just multiply by dy by dx. Before looking at an example, let's go through the steps which are required to find the second derivative implicitly. So the first thing we've got to do is differentiate as normal, and obviously we're talking about an implicit situation here, so we're going to get some dy by dx is turning up. Then we're going to rearrange to make dy by dx the subject, and then we're going to differentiate again, and obviously if we differentiate a dy by dx, we'll get a d2y by dx squared. Anyway, when we have the implicit parts, we're going to end up with some more dy by dx's, and we're going to substitute those for the answer that we got here, and that is going to be our answer. Okay, let's have a look at an example. See, I have the equation of a circle, and I want to find its derivative dy by dx, and I also want to find its second derivative. So I'm going to differentiate. So x squared goes to 2x. Y squared I can't differentiate with respect to x, so it goes to 2y, and we multiply by dy by dx from that initial formula that we got, and 5 goes to 0. We're now going to rearrange that to give us dy by dx equals minus x over y. We've taken the 2x to that side, and we've divided by 2y. So now we're going to differentiate again, noting that this is a quotient, and we get d2y by dx squared equals minus y plus x dy dx y squared. And you can see this is the bit that we don't really want. However, we know that dy by dx equals minus x over y, so substituting for that gives us this formula here. And obviously you don't want fractions within fractions, so we're going to multiply everything by y, and we get d2y by dx squared equals this formula here. Note that y squared and x squared are always positive, so minus y squared minus x squared is always negative. And that would shows why when we put in a positive y value, we're going to be looking at a maximum type situation, or a concave down situation, and when we're putting in a negative y value, we're going to get a concave up situation. In the description below you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Staying in field with Winfield.